We live in a three-dimensional world. We see length, width, and height, but what if there's more? What if our reality is just a slice of a bigger picture? Imagine a world with an extra dimension, a fourth dimension beyond our comprehension. This is the realm of hyperspace, a place where our understanding of physics is turned inside out. For centuries, mathematicians and physicists have grappled with the concept of higher dimensions. Albert Einstein's theory of relativity added fuel to the fire, suggesting that time itself might be the fourth dimension. But what does it mean for something to exist in four dimensions? Can we, as three-dimensional beings, ever truly grasp such a concept? The fourth dimension is often described as being perpendicular to our three dimensions, just as a two-dimensional being living on a flat surface couldn't grasp the concept of up. We struggle to visualize a direction outside of our familiar length, width, and height. Our brains simply aren't wired for it, yet even if we can't physically experience the fourth dimension, we can use mathematics and imaginations to explore its possibilities. And what we find there is both fascinating and deeply unsettling. To understand the fourth dimension, we need to break down the concept of dimensions themselves. Imagine a single point. It has no size, only position. This is 0 dimensions. Now, connect 2 points with a line. The line has length, representing 1 dimension. Extend that line to create a square, adding width and giving us 2 dimensions. Finally, add height to the square, forming a cube with 3 dimensions. This is the world we perceive. But what happens when we add another dimension to the cube? We enter the realm of the hypercube, also known as a tesseract. This 4-dimensional object is impossible to visualize fully in our 3-dimensional world. Just as a 3-dimensional object casts a 2-dimensional shadow, a 4-dimensional object would cast a 3-dimensional shadow in our world. Imagine a cube constantly unfolding, with sides appearing and disappearing, seemingly defying the laws of physics. That's a glimpse into the bizarre nature of 4-dimensional space. The human brain is wired to process a 3-dimensional world. Our senses and movements are based on these 3 dimensions. Can we ever truly experience the 4th dimension, or are we forever trapped in our 3-dimensional prison? Think of a garden hose. From a distance, it looks like a 1-dimensional line. But up close, it has a 2nd dimension, curled up in a circle. Could the 4th dimension be similar, hidden in plain sight? Imagine a 2-dimensional being living on a flat surface. It could only perceive other objects on that surface, moving around them in 2 dimensions. Now, imagine a 3-dimensional object, like a sphere, passing through their 2-dimensional world. What would the 2-dimensional being see? At first, nothing. Then a single point would appear seemingly out of nowhere. This point would grow into a circle, reach a maximum size, then shrink back down to a point before disappearing entirely. The 2-dimensional being would have no concept of the sphere as a whole. It only witnessed a series of 2-dimensional slices. Now apply that same logic to a 4-dimensional being interacting with our 3-dimensional world. It could appear and disappear at will, walk through walls, and even reach inside our bodies without breaking our skin. To us, these actions would seem like magic, but to the 4-dimensional being, it would be a simple matter of navigating its own space. The concept of a 4-dimensional being interacting with our world might seem like pure science fiction. However, it highlights the limitations of our 3-dimensional perception and the mind-boggling possibilities that might exist beyond our current understanding. Section 5. Simulating the unseen, visualizing hyperspace. While we may not be able to experience the 4th dimension directly, we can use technology to create simulations and visualizations that give us a glimpse into its strange geometry. Computer graphics, for example, can render 4-dimensional objects as 3-dimensional projections, allowing us to manipulate and explore their complex shapes. Virtual reality takes this a step further, immersing us in simulated 4-dimensional environments. While we still perceive these environments through our 3-dimensional senses, these simulations can help us develop an intuition for how 4-dimensional space might work. Another approach is to use mathematical models and data visualization techniques to represent 4-dimensional data in a way that our 3-dimensional brains can process. While these representations might not be visually accurate, they can reveal hidden patterns and relationships within complex data sets. By combining technology with our imagination, we can begin to unravel the mysteries of the fourth dimension and explore the vast possibilities of hyperspace. Unraveling the fourth dimension. Mathematics provides the language to explore higher dimensions. We use equations to define hypercubes and other four-dimensional objects. In four-dimensional space, we add a fourth coordinate, w. Mathematicians calculate properties of four-dimensional objects. Shapes can fold and unfold in impossible ways. Studying these models reveals the nature of space beyond our experience. Section 7. The fabric of the cosmos, higher dimensions in modern physics. The concept of higher dimensions isn't limited to the realm of mathematics and abstract geometry. Modern physics, particularly string theory and M-theory, suggests that our universe might actually have more than the three spatial dimensions we perceive. These theories attempt to unify all the fundamental forces of nature, including gravity, into a single framework. To do so, they propose that the universe is made up of tiny vibrating strings that exist in a 10 or 11-dimensional spacetime. The extra dimensions, beyond our familiar four, are thought to be compactified, curled up at incredibly small scales. While these extra dimensions are currently beyond our ability to detect directly, their existence could explain some of the most perplexing mysteries of the universe, such as the weakness of gravity compared to other forces and the behavior of black holes. The exploration of higher dimensions in modern physics is a testament to the power of human curiosity and our relentless pursuit of understanding the universe and our place within it. Section 8. Beyond science fiction. The philosophical implications of 4D space. The concept of a fourth dimension has captured the imaginations of philosophers and science fiction writers for centuries. It raises profound questions about the nature of reality, perception, and the limits of human understanding. If a fourth dimension exists, what does it say about our own existence? Are we merely shadows of our four-dimensional selves, forever limited by our three-dimensional perception? Could there be other beings existing in higher dimensions who are completely unaware of our presence? The exploration of higher dimensions challenges our fundamental assumptions about the universe and our place within it. It forces us to confront the limitations of our senses and the possibility that reality might be far stranger and more complex than we ever imagined. Whether or not we can ever physically access these higher dimensions, the very act of contemplating their existence expands our minds and pushes the boundaries of human thought. Section 9. The unending quest, our future with higher dimensions. The quest to understand higher dimensions is far from over. As technology advances, we may develop new tools and techniques that allow us to probe the fabric of reality at even deeper levels. Perhaps one day we will be able to detect the subtle signatures of these extra dimensions, providing concrete evidence for their existence. Even if we never achieve direct observation, the exploration of higher dimensions will continue to drive scientific progress and inspire new generations of mathematicians, physicists, and dreamers. The pursuit of knowledge knows no bounds, and the mysteries of the universe will continue to beckon us forward. The study of higher dimensions is not just about unraveling the secrets of the cosmos, it's about pushing the limits of human imagination, expanding our understanding of what's possible, and asking the big questions that drive us to explore the unknown. It's a journey that will likely continue for generations to come, constantly reshaping our perception of reality and revealing the true nature of our universe. Section 10. A universe of wonder embracing the unknown. As we stand at the precipice of the unknown, gazing out into the vast expanse of the cosmos, we are reminded of the power of human curiosity and our insatiable thirst for knowledge. The concept of higher dimensions, once relegated to the realms of science fiction, now occupies a central role in our quest to understand the fundamental nature of reality. While the journey to unlock the secrets of hyperspace may be long and arduous, it is a journey worth taking. For in the pursuit of the unknown, we discover not only new truths about the universe, but also new truths about ourselves. We are reminded that our capacity for wonder and our desire to explore are what make us human. So let us embrace the unknown with open minds and a sense of adventure. Let us continue to ask the big questions, push the boundaries of knowledge, and explore the infinite possibilities that lie hidden within the fabric of the cosmos. For in the words of Carl Sagan, somewhere, something incredible is waiting to be known.